This video, I'm going to go through a pretty difficult discriminant question actually. I'd even grade this as an A-star level question. So it tells you that this equation has no real roots. So let's start by reminding ourselves of what we know about discriminants. We know the discriminant is b squared minus 4ac. What we get from that is the fact that quadratics are written in the form ax squared plus bx plus c. A is the term before x squared, b is the term before x, and c is this constant at the end. If you take b squared minus 4ac, you find that it's either less than 0, you can find that it's equal to 0, or you can find that it's larger than 0. And what do each of these three options mean? Well, first of all, when it's less than 0, that means that the quadratic that you're taking the discriminant of has no roots. Whereas if it's equal to 0, that means that there's exactly one root. An example of this is x minus 3 all squared equals 0. Although this is a quadratic, only x equals 3 is the valuable solution from this. If b squared minus 4ac is larger than 0, then we say that there's two roots to the quadratic. This is what we get most of the time. For example, x minus 5, x plus 2 equals 0. If you factorize a quadratic and you get to this point here, you can get x equals 5 or x equals minus 2. That's two different solutions. Moving on then, what do we apply to this scenario, or how do we apply to this scenario? Actually, I'm going to change the thickness of the pen very quickly. But it tells you that this quadratic has no real roots. What that means is we can take the discriminant of it and set it as being less than 0 and form a quadratic inequality. So let's do that. Like I said, a is the coefficient of x squared, so it's 1 for this example. B is the coefficient of x, so it's all of 2k minus 3. And c is the whole of the constant at the end. I'm sorry, I got a little mixed up there. So c is going to be this constant here, k plus 3. It tells you that k is a constant, so k and 3 combined make up our constant. Substituting into this discriminant part, we get b squared, which is 2k minus 3. Sorry, I've been told my k looks awkward. Sorry about that. So b squared minus 4. I like to put everything in brackets, by the way, just to reduce errors. Multiplied by c, k plus 3. Now, when you square a bracket, that's just the same as multiplying the bracket by itself. So I'm going to write this out as 2k minus 3 multiplied by 2k minus 3. 2k times 2k is 4k squared. 2k times minus 3 is minus 6k. Minus 3 times 2k is minus 6k again. You may have noticed that it's like terms, so let's combine those to make minus 12k. And then we have minus 3 times minus 3 is positive 9. Okay, so 4 times 1 is just 4, so I'm going to honestly just replace these two brackets with a 4 to make it easier. Minus 4 times k is minus 4k. Minus 4 times 3 is minus 12. Combining the like terms, minus 12k minus 4k is minus 16k. So we get 4k squared minus 16k, and then 9 take away 12 is minus 3. And we set all of that as being less than 0. Great. Now we have to factorize it somehow. You may have very quickly realized that when you do 4 times minus 3 and minus 12, you can't really factorize it here. There's no numbers that multiply to give minus 12 but then add to give minus 16. It doesn't make logical sense. That's what tells you that in order to solve this quadratic, you actually have to use the quadratic formula. So let's do that. I'm just going to very quickly write out the quadratic formula. Minus b plus or minus square root b squared minus 4ac all over 2a. Because we're solving this expression here, our a value is the coefficient of k squared. B is going to be the coefficient of k, which is minus 16. And c is going to be this constant at the end, minus 3. Substituting into this formula, minus b is going to be positive 16. Plus or minus square root of b squared. Again, I like to put everything in brackets. So b in a bracket minus 16 all squared minus, and then 4ac in brackets too. So 4 times a, which is 4, multiplied by c, which is minus 3, all over 2a. I'm sure you guys know how to use the quadratic formula. It's from GCSE Maths. You first do it with a minus and you do it afterwards with a plus. I've actually done this beforehand to speed things up, and I got minus 0.18 and 4.18. Let's draw that very briefly on a graph. So we have that this quadratic, if we drew it graphically, we know that it crosses at minus 0.18 and also at 4.18. If we draw the quadratic out, what we're interested in is where this quadratic is less than 0. So where is the curve less than 0? Where is the curve negative? Well, that's below the x-axis. All of these points are where the curve is negative. So what we can say is that in between minus 0.18, or in between when k is minus 0.18 and 4.18, that's where the curve is negative. And that means that's where this quadratic is negative, And that's the set of possible values for k for which this has no real roots, because this quadratic here came from all of this working out that we did beforehand. Pretty difficult question there, but hopefully it made sense to you guys. If you enjoyed the video, be sure to leave it a like and subscribe. I'd appreciate it a lot. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website, www.excellineducation.co.uk. It's on the first link in the description too.